Hi again, folks. Now, in the previous video, I went over how to define some basic examples of closed pocket geometries in iMachining. For this next part, I'm going to define a few examples of open pocket geometries. And I'll also show you the techniques of the iMachining toolpath that are used on such geometries. When watching, just keep in mind what I told you about chain picking. The chain selection order is very important. And just a quick tip, if you ever run into any issues with the toolpath giving you a strange result, I would troubleshoot by first checking to make sure that your chains are selected in the correct order. In any case, now I'll get started with my first open pocket geometry example. So here again I have my cam part on the screen ready to go. These are the three open pocket geometry examples that I'll be working on in this video. So I'll pan over to the first example, which is just a simple open pocket. To add an iMachining operation, I'll go to the SolidCAM Manager, and then I'll right-click Operations, Add Milling Operation, and select 2D iMachining. When the iMachining operation dialog box appears, I'll click the New button to define the machining geometry. Now, as I said before, the geometry for this operation is simply defined as an open pocket. There's only one chain to define, so in the SOLIDWORKS graphics area, I'll pick on the initial contour of the pocket. Top or bottom, it doesn't matter for this example. I'll select Auto Constant Z to close the chain, and then I'll click Yes to accept the chain selection. I'll go to the chain list again, right-click Chain 1, and just choose Mark Chain as Open. It's that simple. The chain turns black for visual confirmation, and now iMachining is informed that the pocket can be approached from the outside. I'll now confirm the geometry definition by clicking OK. Next, I have to make the tool and levels definitions again. For anyone just joining in, all the pockets in this example use the same tool and have the same exact depths. So I'll make those definitions now, and then I'll just use the Save and Copy function to copy them to a new operation for the next example. So moving down to the Tool page, I'll click the Select button to display the Choosing Tool for Operation dialog box. I'll select tool number 1 from the list, and then by clicking Select, I'll exit the Part Tool table. To finish up the operation definition, I'll switch to the Levels page to define the milling levels. I'll click the Upper Level button, and then in the SOLIDWORKS graphics area, I'll pick on the top face of the stock model. This is again the Z level where the machining will start. To confirm my selection, I'll click OK. Next, I'll click the Pocket Depth button to define the machining depth. I'll pick on the bottom edge of the open pocket, and then I'll click OK to confirm the selection. In my continued effort to keep things organized, I'll name this operation Open Pocket. When I click Save and Calculate, the iMachining operation is added to the cam tree, and the toolpath is calculated. I'll then click the Simulate button to open up the Simulation Control Panel. Clicking Play will show the iMachining toolpath approach from the outside, take some material away from the corners, and then clear the entire face with what's called a converging morphing spiral. Now that the wireframe toolpath has come to an end, I'll exit the Simulation Control Panel. I'll now move on to the next example. First, I'll click the Save and Copy button to start a new iMachining operation with all the same settings. On the Geometry page, however, I'll click the New button to define the new machining geometry. Now I first have to pan over to the next example. For this operation, the geometry is defined as an open pocket with island. The first chain to select is the outer chain. So in the SOLIDWORKS graphics area, I'll pick on the pocket contour. Using Auto Constant Z, I'll close the chain, and then I'll click Yes to accept the chain selection. The second chain to select is the inner chain. Again, in the SOLIDWORKS graphics area, I'll pick on the island contour. Then I'll select Auto Constant Z to close the chain, and of course, I'll click Yes to accept. To finish up the geometry definition, I'll right-click the outer chain, which is Chain 1, and choose Mark Chain as Open. I'll then click OK to confirm the geometry selection. This operation I'll name Open Pocket Island. I'll click Save and Calculate to add this operation to the cam tree and calculate the toolpath. To start the simulation, I'll then click the Simulate button. Now when I click play, you'll see that the iMachining toolpath is very similar to the previous operation. The tool approaches from the outside, machines the corners, and then performs a morphing spiral towards the island. Now, let me show you one more geometry dealing with open pockets. First, I have to exit the simulation control panel, and then of course click the Save and Copy button to start a new operation with all the same settings. I'll click the New button to start the geometry definition. I'll bring this last open pocket example into view. Now for this operation, the geometry is defined as an open pocket with multiple islands. The first chain to select must be the outer chain, and then the two inner chains can be selected. So in the SOLIDWORKS graphics area, I'll pick on the initial pocket contour. I'll use Auto Constant Z to quickly close the chain, and then I'll click Yes to accept the chain selection. Next, I'll pick the two chains on island contours and use Auto Constant Z to close the chains. Then by clicking Yes, I'll accept the chain selections. And finally, the chain on pocket contour has to be marked as open. So again, I'll right-click Chain 1 and choose Mark Chain as Open. Then by clicking OK, I'll confirm the geometry definition. I'll name the operation Open Pocket Islands. I'll then click Save and Calculate to add this iMachining operation to the cam tree and to calculate the toolpath. Then, I'll click Simulate. Now I'll click the play button to display the wireframe toolpath on the model. The tool approaches the pocket from the outside and collapses in towards the islands. The first island that's encountered is separated, and then a final morphing spiral is formed around the second island. Well, that just about does it for the open pocket geometry examples. These are again just basic examples, but I hope they give you good insight to how open pocket geometries are defined in iMachining and some of the techniques that are used when cutting those geometries. Join me for the last part in this series, where I'll show you how several types of semi-open pocket geometries are defined in iMachining.